everyone. I really want to thank NVIDIA and AWS for this opportunity. I'll be talking about the reality of scaling GenAI to massive amount of content. And I will share a real example of one project we did a year ago about that. So you will hear all the goods to the not so good, to the impact maybe on your AWS invoice at the end and how you can prevent that. So we're not going to give yet again a definition of GenAI. We're not talking about GenAI POC, but really scaling GenAI. So the audience of this talk is mostly dedicated to technical decision maker, people that have awareness on GenAI, on maybe AWS services. It's not too techy, I promise, but that's just a bit of a warning on the audience. It can get a bit technical at some point. I'm Fred Petitpont. I'm CTO and co-founder of Moments Lab. At Moments Lab, our promise is pretty straightforward. We promise our customers that they'll be able to find their moment in less than 2 seconds through petabytes of archive, no matter the size. We do that using a technology that is called MXT-1.5. So this technology basically split every content in small chunks, small shots, and we identify all modalities to describe in natural language each shot and then give summary, soundbite, and help our user repurpose content, find content easily, and build new stories and more compelling stories. The one thing to have in mind, our customer, let's take the example of right owners, their content is definitely their most valuable asset. So the way they use it will have a direct impact on their revenue. So that's why how they access it is so key. We've seen that there's a trend for the last 10 years that is growing in how we can reuse all that archive content, whether it's sports, true crime, documentary. I mean, they are so compelling now when you watch that on Netflix, on Prime. This is so impressive. And this is a good example on how they are reusing this kind of content, creating new compelling stories, I think even better than fiction sometimes. Then on the other side, there is also a massive trend in how you can repurpose content right in social media. So I don't know if anyone knows the story behind Bondi Rescue. So Bondi Rescue is the Australian Baywatch. And a production company called Totem basically acquired all the rights, the TV rights, and they decided to do a show for YouTube. So the content is the same that was on air, but it has been totally revamped and re-edited for social media. So with a much more fast-paced approach, and they're saying they're now up to 1 billion views. So it's like really impressive. So it's a good example. Then we do have the classic top 10 moments of Gordon Ramsay shouting at someone. Well, not shouting. I don't want to be too negative, but you get the point. We have one of our US customer. It's a very big network, and they've been there for decades, and they totally understood that. They do have a video library of 200,000 hours. So this is where I will start telling you about this project. And what is interesting is that whole content is about to reach the end of its physical life. Why? Because it sits on that kind of material. So those tapes were designed to last for 30 years. And a lot of this content is already 55 years old. So the problem is it's not easily accessible, right? So that's the first problem. But the second one is there are a lot of those tapes. So you can reach LA to New York City. And this content is mostly about America, news, politics, some entertainment, some sports. So it's a good analogy, right? But of course, no annotation, no indexing. Sometimes a date, but you're not even sure. So this is where our mission begins. How can you make that content available so fast before it ends, before it reaches the end of its physical life? So of course, like in any impossible mission, you need a good team. what we did here was one of the most challenging part, which is how can you detect, discover those hidden gems in 200,000 hours of video content. And so we use our MXT technology, but a year ago, I mean, it was like analyzing up to a few dozen hours, 40 hours per day, but it had never reached that speed of like almost 200,000 hours per day. So like any impossible mission, you need a good support, you need a team. AWS was there to help us grow, scale our system, MXT. If you look back, that MXT technology was in general availability a year ago at IBC. And since then, it has run on that project and few other projects like that one, and over hundreds of thousand hours of video. And I want to share the challenges that we encountered and the mistakes we did. It's important. And I guess the first challenge we had is in the early design we did at MXT, we choose to use a lot of CPU rather than GPU. The system was designed to run at 500 hours per minute in terms of speed of analysis. And we knew that at that time, GPU resource was kind of scarce, so it was not easily accessible, so we choose to rely more on CPU. So we used a lot of lambdas, a lot of EC2s, and we used a lot of quantization model. I don't know if you know quantization is. It's basically the capacity to super optimize a model so it can run on like a more modest CPU, let's say it like this. And it was a mistake. We should never have done that. It's good when you do have like 20 hours of content to analyze every day, but when you had at that pace, this is not optimal. So we quickly moved all of that load to GPU load using SageMaker endpoints, and that started to be really different. Now we traded one problem to another. I mean, this kind of problem you discover bottleneck every day, right? So once you solve the problem, there is another one. Or the other one is managing the load. So quickly enough, we basically deployed auto-scaling on each of our SageMaker endpoints, which are scaling very, very well. Good job, AWS, on this one, because it's super impressive. But one thing to have in mind when you do this kind of project, of course, so you improve the product and you want to demo the product. And you got to have in mind that when you analyze, I mean, you got results that can appear super quickly. And let's say you share that with your sales team, for example, that needs to sell the product. They want results to be displayed super quickly. But when you analyze 100,000 hours of video, you can't afford to have that. It's best to process by batch. So that's why I'm kind of watch out for demo effect. You can build a system for a demo, but you got to be very careful if you want to run it at scale, because you might not want the result to be displayed as fast as if it's not for a demo. The next challenge is about quality. Of course, we're talking about GenAI. We're talking about LLMs that have been frozen in time at some point. So they might predict stuff that is wrong. And there is a big risk because you can literally start a war with some hallucinations. So you need to evaluate carefully models. Use of RAG is a good way to balance quality. But yeah, I mean, this is very dangerous. And I'm not even talking about this one. I don't know if you do have any Newcastle fans, but this is not Juventus, definitely not. And I think the family of my wife would kill me for that, but they're not here. So how do you balance that? What we discovered is it takes as much time to create a system that would explain the quality of your initial system. And I think this is a feedback we had also from NVIDIA engineers working on a self-driving car. It takes as much energy to develop a system that will explain the decision the car is doing than actually having the initial software. So again, doing that right will help win the trust of the users. Maybe it's my favorite one. I don't know if you know this guy. He's doing a YouTube video that are super cool about DevOps and so on. But for all people that have access to the AWS console and Cost Explorer, it's a bit blurry here, But when you are up to 2,000% of the of the previous bill, but for the first current week, you can be crazy. So how do we fight that? I mean, it's kind of normal. I mean, you're using more resources, so the bill is going up. And I think my advice, if I can, on this one, I mean, it's more to open transparency of the cost with the developers. So this is what we did, but we did not do that very early. I think at some point when you are an engineer, you like to have proper KPI, like proper metrics to understand your work. And the Cost Explorer, in the assumption that you're using tags and resources properly, is a perfect tool for that. So we want to get down to a point that any software engineer, any block, any methods, they have an idea of how much it costs. And you don't have to tell them, okay, it has to run 20% faster because I want to make savings. No, just share the cost, and by themselves, they will work to improve it. So far, life in production is pretty good. I think we reached at some point 42 days of content analysis in a single day. So that's pretty cool. We do have a good cost predictability. I think I want to highlight something. The type of content really plays a major role. So if you analyze, for example, sports content, I mean, the frequency of analysis is way higher, embeddings are way heavier than if this is just a press conference or a debate. So it can have a huge impact on cost. I think it's the same for, let's say, translation. You want that to be accessible in several languages. Keep in mind that when you're using LLM or generative AI, I mean, the number of tokens and requests will actually have a high impact on resources. And as a testimony of things that are going well, there are two actually upsell with this customer. I think what they did not realize, they did want to actually index all that archive to sell that archive. 1 minute of content can be sold between $600 to $15,000. But what they did not realize is when they, on a journey of selling that content, they discovered hidden gems and they could build new content. Like, okay, we've been talking a lot about the DNC a few weeks ago, but what if you have access to the DNC content of the one 30 years ago? Well, you can do a parallel and you can build new stories out of that. So a few takeaways. When you build early, sometimes there might be like a grain of sand in the gears that might be okay at low scale, but that would break the machine. And sometimes I think we do have intuition of stuff that can go bad. Listen to yourself. I mean, in terms of design, technical design. The quality is one thing that, I mean, we have to manage user expectations. You have to make sure that the customers and users know that we're using generative AI. So there is, sometimes, it's not going to be 100% perfect. It's like, I mean, transcription like 5 years ago. I mean, early on, user expectations were very high. It has to be 100%, but it's very hard to get to 100% transcription. It can, with a very good signal-to-noise ratio. It can with someone talking English without too much accent, not like me. But that's something to have in mind. Third, it's just about the cost. I mean, the cost is everything. If you look at it, automobile existed in the 1900s, but they were only used in the 30s because they were cheaper than a horse. And it's the same for that kind of technology. And I deeply believe that this is down to human organization. Share transparency on cost, share KPI to your team in terms of cost per component, and you don't have to do anything else as long as the data is accessible. Break barriers between software engineer, AI researchers, and product designer. That's a good example. If you use ChatGPT on prompting, so we're not talking about prompting here, but a nice example is the answer is streamed. If you use Mixtral through Hugging Face, there is no streaming of the answer. So the perception might look way slower, but actually the speed is the same. So I think product designers have to be involved early on in the design and know the technical constraint. And the last point is, I think it always changes. And you have to always improve, always look for new models, or well, look to fine-tune and look for biases that we can fight. We made many mistakes scaling GenAI, and I hope you won't have to. But if you do, let's talk. It will be a common point we have and common point of discussion. Thank you so much.